If we look at various types of machines, it is often found that there is a shaft that comes out of the engine housing where the shaft is used to transfer the power, either generated from the engine or just move and change the direction, torque, speed, and so on. Because it moves, the components inside the machine experience friction, so lubricants are needed to reduce friction and heat. Oil seal is one of the components on the machine that serves to prevent leakage of fluid or lubricant through the rotating shaft. Because of that, your engine doesn't wear out, overheated, or get damaged due to lack of lubricant. To know more about what an oil seal is, you can see in the cross-sectional image of the machine below. Oil seal is a ring-shaped component where the main component is based on rubber and rubber derivatives such as fluoro-rubber or nitrile rubber. Oil seals can also be made from elastomers, which are plastic derivatives that are similar to rubber. Metal insert is a ring made of metal. The point is to strengthen the construction of the oil seal due to the nature of the rubber or elastomer, which tends to be elastic. The oil seal does not always have a metal insert in it. The seal lip edge is the part of the seal that holds the fluid or lubricant in the engine from leaking out through the gap between the shaft and the engine housing. At the top of the seal lip edge there is a garter spring, which is a spring that extends in the form of a ring around it. The function of the garter spring is to press the seal lip edge so that it always presses firmly on the shaft so that there is no gap that allows lubricant or fluid to leak out. Then there is a dust lip which functions to prevent external contaminants such as dust or water from entering the engine through the gap between the oil seal and the shaft or filling the empty space between the seal and the shaft. The first function of the oil seal is to prevent leakage from the media inside the engine housing to the outside by passing through the gap between the shaft and the engine housing. On the engine shaft that protrudes, there will always be a gap between the shaft and the engine housing. This gap allows the medium in the form of water, lubricant, or gas to easily exit the engine housing through the gap between the shaft and the engine housing. If the lubricant comes out, it can cause the amount of lubricant to decrease, which causes the engine to wear out and be damaged due to lack of lubrication. The oil seal closes the gap between the shaft and the engine housing so that there is no medium in the engine housing that can easily leak out when the shaft is stationary or rotating. And your engine runs well without a lack of lubricant or no leakage of working fluid. The second function of the oil seal is to protect the inside of the engine from contamination by foreign objects from the outside that can enter through the gap between the shaft and the engine housing. The engine shaft that protrudes out will be in contact with environmental conditions where there are various media that can enter the engine through the gap between the shaft and the engine housing. Conditions such as rain or the shaft protruding underwater allows water to enter. Dusty conditions also allow dust particles to enter the engine compartment. The oil seal closes the inlet so that no contaminant from outside can enter. Simply put, the oil seal protects the engine by closing the gap between the shaft and the engine housing and separating the conditions inside the engine from conditions outside the engine. The third function of the oil seal is to keep the shaft temperature cool even though the oil seal is constantly rubbing against the rotating shaft. The oil seal is designed to minimize friction by minimizing the contact between the seal lip edge and the shaft so that the temperature remains cool. In its application, seals have different materials and cross-sectional shapes to suit different operating parameters such as the type and pressure of the fluid in the engine, shaft rotational speed, working temperature, shape and dimensions of the seal housing, as well as external environmental conditions where the machine will be operated such as weather, humidity, temperature, outside air pressure, corrosivity, immersed in water, immersed in mud, flammable gas area and so on. After knowing about the function of the oil seal, the following are the steps for installing the oil seal correctly. Check the physical condition of the oil seal to be installed, both from the outside and the inside of the oil seal. Check the condition of the garter spring and the condition of the outer diameter for damage. Check the condition of the edge of the seal lip for damage or cracks. Broken seals cannot be installed. Apply sufficient grease to the inside of the seal. Apply sufficient grease to the inside of the seal before installing the seal. Install the seal with even pressure on the entire surface of the oil seal side. Make sure the oil seal is installed perpendicular to 90 degrees to the axis of the shaft. If available, install the seal using a special press machine. Do not use the hammer directly to hit the seal as the pressure is uneven. Check seal surface flatness after installation. Use the special tool from the oil seal manufacturer if available. To install an oil seal on a shaft that protrudes a long way out, you can use a special tools from the oil seal manufacturer. Use a solid cylinder to attach the oil seal to the bore. When hitting the hammer, alternate crosswise so that the pressure is evenly distributed.